This is SpaceTime Series 26, Episode 36. Coming up on SpaceTime, ExoMars back on track for the Red Planet, an extremely rare coronal mass ejection event on the Sun, and China spying on other nations' satellites as it launches 2 more of its own satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The European Space Agency says its ExoMars mission to the Red Planet is back on, with a likely launch window opening in October 2028. The news comes exactly a year after the launch of the mission was put on hold following the Russian invasion of Ukraine. The Kremlin's actions triggered a range of sanctions against Moscow, including putting a stop to all cooperation in space missions other than the jointly operated International Space Station. That meant Russia could no longer launch its rockets from the European Space Agency's Kourou spaceport in French Guiana, forcing Russian Space Agency Roscosmos launch crews to leave. And the Europeans refused to place their payloads on Russian rockets, forcing customers to find other launchers. Among the many missions affected was the second part of the ExoMars mission. The first part of the program launched in 2016, placing the ExoMars trace gas orbiter into Martian orbit and releasing the European Schiaparelli lander to descend down to the Red Planet's surface. The orbiter remains operational and is providing data. However, the lander crashed during the descent. The second part of the ExoMars mission was originally slated to launch in July 2018 using a Russian Proton rocket from the Baikonur Cosmodrome. On board will be the Russian Kozychek Mars lander, which would deliver the European Space Agency's Rosalind Franklin rover down to the Martian surface. The landing site was Oxia Planum near the Martian equator, which was selected because of its potential to be a likely place to host preserved biosignatures if they ever existed on Mars, and also because of its smooth surface, making the landing easier. ESA's Rosalind Franklin rover is unique. It's capable of drilling down 1.7 metres below the Martian surface. That's some 25 times deeper than any other rover. And that's important because scientists speculate that if life does exist on Mars today, 1.7 metres is about the depth at which it's likely to be living. See, that's deep enough to keep warm, have access to moisture, and avoid the dangers of irradiation or the freeze-dried environment on the surface and in the atmosphere. But funding issues, as well as technical difficulties both with the lander as a result of problems with the parachutes and with the payload scientific instrument, followed by travel restrictions due to the COVID-19 pandemic, delayed the mission until 2022. Then came the Russian invasion of Ukraine, resulting in sanctions against Moscow, which finally saw the already delayed ExoMars mission abandoned. ESA is instead partnering with NASA, and a new launch schedule was developed, with liftoff slated for October 2028. In this report from ESA TV, we look at what's happened since the mission was cancelled, the plans ahead, the new challenges, the latest deep drilling tests, and the stringent planetary protection measures in place.
Has life ever existed on Mars? And could life have survived and evolved for billions of years? In their insatiable quest to find life in other parts of the universe, humans have often looked at the Red Planet. After all, Mars is a rocky planet like Earth, orbiting the Sun and at a distance where water could have been present in the past. We are unlikely to find Martians on Mars, but tiny traces of ancient rivers, lakes or even oceans could give us fresh clues about whether some sort of life could have developed. Finding these fresh clues is exactly what the ExoMars mission is all about. It aims at sending a rover to the Red Planet to explore and retrieve samples from its soil. After many years of testing and fine-tuning, the rover was due to be launched into space in 2022. But events on Earth thwarted these plans.
The war in Ukraine has had a massive impact on our work.
Pietro is the ExoMars rover manager for ESA. He's come to oversee some tests in Turin, where the rover and its Earth twin are housed.
We were ready to go to the launch campaign for ExoMars, and we had all of a sudden to stop and to reconsider our plans.
So I suppose it's been quite tough for the teams as well.
Yes, for the team it's been very, very difficult to digest this decision, because they've been working very hard in the last years, and it was indeed difficult also from a human perspective. But of course they understand the political implications, so they managed to let's say reset and to start working on a new enterprise, which is the ExoMars rover in Franklin mission.
So what are the new plans really for ExoMars?
The new plans are to build a new lander, this time an European lander. The previous one was built also with the help of European industry, but was mainly Russian-made. This time we will be building it completely in Europe, with some contribution from NASA that we might need for the propulsion system.
So we'll have a new European lander, we'll have a refurbished rover. What's the timeline? When can we hope that the rover will be launched?
We are now targeting a new launch opportunity in October 2028. Cannot be earlier, because we need time to build, to redesign and build and requalify the lander. So there is a certain time that is needed for that. We don't want to go beyond this date, because then the environmental conditions on Mars are not favorable for the mission that we want to do with the rover.
Despite these turbulent times, preparatory activities for a trip to Mars never really stopped, and tests are picking up again in the home of Amalia, the Earth twin of a real rover.
Amalia lives by the Mars Yard, a large hangar filled with 140 tons of soil that simulates the conditions the rover will encounter on Mars. Amalia is a replica of a real rover. It enables engineers to rehearse various scenarios that the real rover might encounter in a harsh Martian environment, helping them to make key decisions.
So Andrea, we met about a year ago during the wheel walking tests, and of course a lot has happened since then. So how did your team handle the events on Earth?
Well, it was of course tough. So we were on the climax. We were at the end of a big test campaign, both on the GTM, on the Amalia side, and on the protoflight model for the preparation for the transfer to the launch site in Baikonur. So after the climax, there was of course the team faced some difficulty to accept the change of paradigm of the new mission, but then we took it as an opportunity. The team has been renewed. We have a lot of newcomers with a big positive spirit, and we are facing again this as a new challenge that we are used to manage.
And so what is going to happen then in the next few months, few years? The mission is changing slightly, so what are your plans?
The rover was accepted and qualified for the 2022 scenario. We are now facing a new mission scenario, and the idea is to upgrade the rover in order to be capable to survive what is called the global dust storm season, so a bad season on Mars with a lot of dust suspended. So we are going to implement all the means that are necessary to survive such environment, like tiltable solar arrays, larger part of array choose, so nuclear power to keep the rover warm. Of course, we need the time to build all what is necessary to build around the rover, and that is probably going to take 4-6 years, and that is the time frame we have to upgrade the rover and to make it more attractive for the engineering and scientific community.
So I have one very simple last question is, of course, we've got the rover up there and it's hanging from the ceiling. So I know there's something about gravity on Mars that's involved.
So what we need to simulate on Earth is the same gravity as on Mars, that is 1/3. So we created a ground support equipment that is the rover offloading device that basically pulls the rover of 2/3 of its weight. And through that we were capable to really demonstrate the functionalities of mobility and drilling in a representative environment.
The next day, the drilling test is finally ready to begin.
Okay, Daisy Rock, we are ready to send the commands to collect the sample at 1.7 meter depth. I will give it on my mark, so 3, 2, 1, mark.
The Earth Twin rover will try and drill into a clay stone at a depth of 1.7 meters, much deeper than anything other rovers have ever attempted on Mars. Such a depth will offer access, it is hoped, to organic material from 4 billion years ago, when conditions on the surface of Mars were more like those on the infant Earth, enough to make engineers feel a bit nervous.
So this is the control room where engineers and scientists are sending commands to the rover and receiving its data back. There's a rather large amount of information to handle.
Tazi Rock, can you please report the execution of the command status, please? We are standing by.
The test is conducted in real time. Commands are sent to the rover, but it takes hours before it starts moving, the same time it will take for data to travel from Earth to the Mars surface. After many hours of commanding and data analysis, the drill is finally retracted. The sample is then dropped into a drawer, which withdraws and deposits it into a crushing station. The resulting powder is distributed to ovens and containers to perform the scientific analysis on Mars. The rover is a real laboratory on wheels.
It has been a very long testing day. The test has been very successful. We have been able to collect the sample at 1.7 meter. We have been able to take it out, and now the sample has been delivered to the rover for further processing. So we are very happy and very proud of the performances of the rover.
While its Earth twin is being submitted to further test, the real rover, the one that is due to fly to Mars, is carefully stored in an ultra-clean room. The rover is waiting for further pampering in one of the cleanest places on Earth.
Entering that room was no easy task when we visited last year. Strict hygiene measures and layers of protective clothes were, and still are, in place.
Entering clean room and then an ultra clean room to see something that's gonna touch the soil of Mars, and feel pretty lucky actually. Let's go.
Welcome to the clean room, the antechamber to the ultra clean room. Scientists working here only wear one layer of protective clothes and then enjoy a wonderful view of the real rover, carefully stored behind thick glass walls.
So all the material that's going to go inside the ultra clean room needs to be thoroughly cleaned, and that's going to take at least an hour.
Chemical agents are used to clean the equipment, but anything located inside the ultra clean room itself went through numerous cleaning cycles, including dry heat treatment. Our host, Enrico Andrea Nistico, is a planetary protection engineer. And, as his job title suggests, he's here to make sure we, like all personnel working here, respect the most stringent rules. Protecting other planets from terrestrial contamination is actually a legal obligation under the UN Outer Space Treaty. That's worth another layer of protective garment.
Francesco has done all the meticulous preparation again, and it's taken him about an hour, and is now finally filming the real rover in its ultra-clean room.
The buzzing activity we witnessed in that room last year has somehow subdued. The Rosalind Franklin rover is now patiently waiting in its ultra-clean room for some big decisions to come. The road to launch, now planned for 2028, remains long indeed. Europeans need to devise new ways to develop a lander and upgrade all the existing hard and software in the long journey to Mars.
And in that report from ESA TV, we heard from ExoMars Rosalind Franklin mission team leader Pietro Baglioni, the head of robotics with Thales Alenia Space Andrea Merlo, RDCC systems engineer Diego Bussi, and planetary protection engineer Enrico Indiani-Stico. This is SpaceTime. Still to come, an extremely rare type of coronal mass ejection event on the Sun, and China spying on other nations' satellites as it launches 2 more of its own spy satellites. All that and more still to come on SpaceTime. A blast, which scientists are calling an extremely rare bright coronal mass ejection event, has just rocked the surface of the far side of the Sun. The blast was detected by the joint NASA and ESA Solar and Heliospheric Observatory spacecraft, SOHO. The event was recorded by SOHO with a CME halo travelling away from the Sun at over 3,000 kilometres per second. Astronomers say the high velocity appears to put it in the category of a decade-class event, a fast mover that only happens once every 10 years or so. A coronal mass ejection happens when a massive explosion on the Sun's surface sends billions of tons of plasma magnetic field out into space. These blasts are triggered by solar flares, which fling a mass of energy out from the Sun as a result of magnetic field line loops snapping in the solar atmosphere. The explosion from this coronal mass ejection was so powerful, it still managed to pepper the Earth with energetic particles propelled by the event shockwave, even though the blast was not directed towards the Earth. NOAA, the National Oceanographic and Atmospheric Administration's GOES-16 satellite, detected the particles as they reached the Earth from the CME's backside. The Earth's magnetic field then funneled the particles towards the planet's poles, where a type of radio blackout called a polar caption absorption event took place. Scientists think the eruption was likely to have hit NASA's Parker Solar Probe head-on. The spacecraft is currently nearing its 15th closest approach to the Sun, or perihelion, flying within 8.3 million kilometres of the Sun on March the 17th. On March 13, the spacecraft set a green beacon tone showing that it was still in nominal operating mode. Scientists and engineers are awaiting the next data download from the spacecraft, which will occur after closest approach in order to learn more about the CME event and any potential impacts. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, China caught spying on other nations' satellites as it launches 2 more of its own spy satellites. And later in the science report, a new study claims high blood caffeine levels could possibly curb body fat and the risk of type 2 diabetes. All that and more still to come on SpaceTime. It's been revealed that a Chinese spy satellite launched in 2018 has been inspecting and possibly even interfering with other nations' spacecraft in geostationary orbit. After its launch, the TJS-3, which Beijing claims to be a harmless telecommunications satellite, did something telecommunications satellites never do. It released a smaller satellite. The orbital data shows the spacecraft has been inspecting other nations' satellites, passing to take a closer look at American satellites USA 233 and 298, both of which are military communications satellites operated by the US Space Force. Meanwhile, China's launched another 2 of its own Earth observation satellites as it continues its build-up to war. The twin Tianhui 6 spacecraft were launched aboard a Long March 4C rocket from the Taiyuan Satellite Launch Center in China's Shanxi province. Beijing claims the spacecraft are designed to conduct geological surveys, land resources investigation, and scientific experiments. The United States Space Force's 18th Space Defense Squadron tracked the launch, and it monitored the satellites as they entered their 890-kilometer-high sun-synchronous orbits. The launch came on the same day that China launched a second remote sensing satellite, this one for Egypt, just weeks after lofting another remote sensing satellite for Egypt. The mission was aboard a Long March 2C rocket from the Jiuquan Satellite Launch Center in western China's Gobi Desert. Egypt's Horus 2 Earth imaging satellite followed the earlier launch of Horus 1 by being placed into a 496-kilometer-high sun-synchronous orbit, almost identical to the Horus 1 satellite, which was launched 2 weeks earlier on February the 24th. A few days earlier, China had launched a new telecommunications satellite from the Jiachang Satellite Launch Center in southwestern China's Sichuan province. The Long March 3B rocket carried the ChinaSat 26 telecommunications satellite into geostationary orbit. The spacecraft is designed to use the Dongfeng Hong 4E structure platform to connect user devices mounted in cars, ships and aircraft to high-speed broadband internet. China now has an estimated 614 satellites orbiting the Earth, including over 261 Earth observation, surveillance and reconnaissance satellites, including at least 47 Go-Feng and some 112 Yaogang spy satellites. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study suggests that high blood caffeine levels could curb the amount of body fat a person carries, as well as their risk for type 2 diabetes. The findings, reported in the British Medical Journal, looked at 2 common genetic variants of the CYPA1A2 and AHR genes, which are associated with the speed of caffeine metabolism in 10,000 people of European descent. Using a technique called Mendelian randomization, which uses genetics to allow scientists to determine whether one thing causes another rather than them just being linked, scientists found people who carry the genetic variants associated with slower coffee metabolism drink on average less coffee, yet have higher levels of caffeine in their blood compared to people who metabolize it very quickly in order to reach and retain the levels required for its stimulant effects. The results showed higher genetically predicted blood caffeine levels were associated with a lower weight and body fat, as well as a lower risk of type 2 diabetes. Australian scientists have discovered an enzyme that can literally make energy out of thin air. The findings, reported in the journal Nature, reveals that the enzyme uses the low amounts of hydrogen in the atmosphere to create an electrical current. The hydrogen-consuming enzyme is produced by a common soil bacterium called Mycobacterium smegmatis. The bacteria uses hydrogen from the atmosphere as an energy source in nutrient-poor environments. But this is the first time that researchers have extracted the enzyme responsible for using atmospheric hydrogen from the bacterium. They showed that this enzyme, called HUC, turns hydrogen gas into an electrical current. Unlike all other known enzymes and chemical catalysts, HUC even consumes hydrogen below atmospheric levels, as little as 0.00005% of the air you breathe. Laboratory work shows that it's possible to store purified HUC for long periods because it's astonishingly stable, and even possible to freeze the enzyme or heat it to over 80 degrees Celsius, and it still retains its power to generate energy. Scientists say it looks like some dogs, those that get anxious, might have differently wired brains. The findings, reported in the journal PLOS ONE, looked at the brains of 25 healthy and 13 anxious dogs using MRIs and compared the brain connections of each dog. They found brain connections between the amygdala, the center of emotion and behavior, and other parts of the anxiety circuit, such as the hippocampus, were stronger than normal in the anxious dogs. The authors say that dogs which exhibited fear and anxiousness towards strangers, as well as excitability, were more likely to have brains showing abnormal network metrics in the amygdala. Certified organic agriculture now accounts for over 75 million hectares globally, with over half of that being in Australia. Organic foods are usually crops, as well as meat and other animal products such as milk, cheese, honey and so on, which have been produced without the use of synthetic pesticides or fertilizers. Some people broaden that description to also exclude genetic modification along with certain preservation techniques such as food irradiation. In addition, some organic meats and animal products also state that they're produced without the use of antibiotics or growth hormones. It all sounds environmentally great and healthy, a win-win. But a new study has shown that while organic foods might taste better than non-organic, and that's a subjective thing anyway, they're often actually less healthy, provide less yield for a given area of land, consume more water, and cost more than their non-organic and genetically engineered counterparts. And the rituals associated with organic farming, such as planting a cow horn full of human feces in the corner of the field in autumn and one full of crushed quartz in springtime, have virtually no scientific support. Tim Mendham from Australian Skeptics says when it comes to organics, the science is clear.
The people who've actually looked at organic food as opposed to standard foods is that they are no healthier and they are no better for you. And the issue is, of course, that organic equals natural, which is a loaded term anyway, because there's a lot of things which are natural which are not good for you. And the issue is about refining what you eat or refining what you use to get it down to the bit that works and the bit that's not going to kill you, hopefully. So people have looked at studies of actually corn was a recent study. Now, corn is a huge crop, and it's obviously, corn is used in so many different products.
It's amazing.
Okay. In America, it's such a huge crop that's used so widely around, but it's used everywhere. And they compared organic corn to traditional corn, normal sort of growing corn, which has changed over the years anyway through sort of breeding practices of different corn. The original corn was horrible. The original maize was a pretty inedible stuff, and the corn you get now is a lot more palatable. But is organic corn better than non-organic corn? The answer is no. It's not as efficient in growing. It takes more land to grow organic corn than it does to grow standard corn. Organic foods can contain pathogens that don't exist in standard products. Organic foods cost more, aren't any healthier for you, and less efficient in growing. Your yield is less on the same area of land. You throw in GMOs, genetic modification, they are highly efficient and very much sort of better for you than the standard corn, not to mention the organic corn. And yet that's the baddie of the green movement.
Foods.
Yeah, Frankenstein foods, because they contain chemicals. And you think everything contains chemicals, right? But they're different because they've been developed by man. They're not natural, because natural things develop themselves. And they have been developed and helped along by mankind for tens of thousands of years. So there are issues. If you want to spend more money on something which says it's organic, which is not necessarily better for you, it might be worse in some cases, which is not as efficient in growing, does it taste any better? It's a matter of preference, isn't it? Go ahead, spend your money.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.